Okay, this video will go through the substitution method for solving systems of equations. So in your packet, if you would go back to the beginning and find the substitution column, which is on the back of the cover sheet. The substitution method is best to use when in the system of equations you have a variable with a coefficient of +1. That's the easiest, the substitution is the easiest method to use when you have a coefficient of +1. Or if it's easy enough to isolate one of the variable has a coefficient of +1 and it's easy to isolate that variable, then that would be the two best times to use substitution. So right now I would like for you to go to page 8 in your packet, and let's do a few of the examples together from page 8. And the first problem that we will do together is number 1. So number 1, you can see that the first equation is already set up so that y equals 6x. So I take the information from the first equation and I make a substitution in the second equation. So I copy the second equation, and instead of writing the variable y, I will replace it with the value of 6x. So I end up with 20x equaling -20, therefore x is -1. Now the solution to a system of linear equations is an ordered pair. So the first coordinate would be -1, that's my x value. I now have to find the y coordinate that goes along with this. So you can go back to either original equation. It's usually smartest to take the equation that's easiest to work with to find the other variable. So if I have y equals 6x, and I know that x is -1, then I find that y is -6. So the solution to this system is the ordered pair -1, -6. Let's do number 3 together next. So here's number 3. And in number 3, you can see that the x variable has been isolated in both equations. So thinking of the reflexive property, x equals itself, you can just simply take both of these equations given in terms of y and set them equal to each other. So if I subtract y and I subtract 7, the value of y is -3. So half of my solution is the y coordinate of -3, and now I have to find the x partner to go along in the ordered pair. And I'll just go ahead and use the second equation. You can use either equation, it doesn't matter, they should both give you the same answer. So x is -3 plus 4, therefore x is 1. So the ordered pair +1, -3 serves as the solution to the system given in problem number 3. Okay, let's look at number 11 together now on the video. So in number 11, analyzing number 11, you can see that I have a coefficient of 2 and a coefficient of -7. So that is not a candidate for easily isolating one of the variables. In the first equation, though, x has a coefficient of +1. So it's really easy to take that first equation and isolate the x. So I would have 84 minus 14y. So it's easy enough to isolate the x in that first equation. And then what I would do is just simply take the second equation, and where the x appears in the second equation, I would substitute in the value that I just calculated from equation number 1, and then just continue on copying the problem. So now you can see that I have an equation in one variable. My variable is y. So this is easy enough to solve for y, and I won't go through all of the detail on the video. You can do that in your own notes, but y is +5. So if y is +5, then I have to find the x value to go along with this. So my solution for number 11, my y coordinate is +5, and now I'm going to find the x coordinate. So when I did my homework, I chose the second equation. The first equation probably would have been easier, but I used the second equation. So let me copy the second equation down right here. And it doesn't matter which equation you use, just take the one that's easiest to work with. But I did this in my notes, so I'll do it on the video. So now y takes on the value of 5. So I end up with 2x minus 35 is negative 7. So 2x is positive 28. Therefore, x is 14. So 14 becomes the x-coordinate in my solution. So the solution for number 11 is the ordered pair positive 14, positive 5. Let's move on and look at number 14 together. Number 14. So you can see in number 14 that looking at the first equation, I have a coefficient of 3 and a coefficient of negative 2. So I'm not going to try to isolate either x or y from the first equation. When I look at the second equation, though, it's easy enough to isolate the x. So from equation number 2, if I add positive 1/2 y to both sides, then x will be represented by 1/2 x. So then I take equation number 1 and I make a substitution. So in place of the x, I'll put the value 4 plus 1/2 y in place of x. And then I'll solve this on the video. You could use the LCD method, but it really doesn't matter. I'm going to just go ahead and do it. And then I'm going to combine like terms. Well, actually, let me subtract the 11. And then I end up with, if I subtract 11, then I have negative 1 over here and 3/2 y. And I'm going to write this with a denominator of 2 so that I end up with negative 1/2 y equaling negative 1. Therefore, y must be positive 2. So the y-coordinate in my solution for number 14 is positive 2. And now to find the x-partner, I'll take the second equation, easier to work with. So now, and I'll switch to red ink. So I'm now going to find the x-partner to go with this. So I'm now finding x. And if I use the equation, x minus 1/2 y equaling positive 4, and I've discovered that y has a value of 2. So I have x minus 1 is 4, therefore x is 5. And I'm sorry, I'm running out of room on my screen. But number 14's solution is the ordered pair positive 5, positive 2. And let's quickly look at word problem number 20. And in word problem number 20, these are so easy to do, so much easier to do now that we can use double variables. So tickets to a movie cost $7.25 for adults, $5.50 for students. A group of friends purchased 8 tickets for $52.75. So the way I like to set these up in a double variable world, I have one equation that represents the quantity, and then one equation that represents the value. So if I let A stand for the adult ticket, and I'll go ahead and say that X is the student ticket, just because my S's sometimes will look like a 5. So I could say that my quantity would be the adult ticket, the number of tickets, the number of adult tickets sold plus the number of student tickets sold should equal 8. I purchased a total of 8 tickets. And then in the other equation, I will attach value to it. So one adult ticket was $7.25, and then one student ticket was $5.50, and then they spent a total of $52.75. So here are my two equations, my system of equations, and you can see that in my quantity equation, it's really easy to isolate either the adult ticket or the student ticket. I isolate one of the variables and then I make a substitution into the value equation, which allows me to then solve this.